last year for the first time, and I thought, when I came in the room like this, I thought, why did I travel all this way? There's only like 40 people here. And it turned out to be an amazing conference last year, and I enjoyed it so much. I'm back this year, and I'll come back every year as long as it's going on. I love it. I've met some of the guys here, like Ryan and his friends, and Melissa, and it's been great. So for those of you that are here the first time, hope you come back. It's a really cool conference. And I also want to apologize to Jay. He was supposed to lead off, and I got confused because I'm old, I guess. And I set up, and they let me go anyway. So thank you. Okay, the name of my session is Remove the M from MVC. Again, my name is Jeff Roberts. My contact information is on the slide. I will post this presentation to I have a GitHub repo with all my presentations, so I haven't done that yet, but I'll do it later so you can get it if you want it. It'll be in the form of a PDF. Everybody hear me all the way in the back even? So a little bit about me. I wanted to talk, I wanted to start off with the creepy clown because Greenville started the creepy clown craze in the US, is that right? The first ever creepy clown sighting was here in Greenville. Isn't that right?
That's right.
So, I'm old compared to you guys. I've been coding for more than 30 years. If you were here last year, this is the exact same slide, so you can sleep if you want. I've been coding professionally since 1986. I've been a consultant since 1991, so 25 years of not being an employee anywhere. And it's been great. I love being a consultant. I've been at Riot longer than I've been anywhere. Riot Games, in case you don't know what that is a company that publishes a game called League of Legends, which is the most played game in the world. The last figures that I saw were that we have 100 million players per month playing the game. We're hiring, by the way, so if you're interested in talking to me, catch me here at the conference. As I said, I've been coding forever in a lot of different languages. Some of them are listed up here. I've been in a lot of different places. Most recently, I've been recording some short screencasts at a site called Brax TV, so check that out. Give me some feedback. My objectives today are to make a proposal to you, but not this kind. More like this, without the sleeping. The proposal is that the model layer in the traditional MVC architecture is unnecessary in many apps. The model layer as we know it. And as John said, feel free to challenge me on this. The thing about me being at Riot for so long is I don't get to get out and see what everybody's doing as much. I have never used core data all that much, and I heard some people talking yesterday about using Realm. I don't use that either. I'm kind of an old-fashioned guy, and I like to do it the old-fashioned way. So in order to communicate this proposal to you, I'm going to sort of form it as a story. And the story is going to kind of lead you through my experience at Riot on the mobile team and how it's been very different than my typical experience when I go to a company to work on some project. That is, as many of you probably experience, when you land on a project, it's usually close to a fixed budget. The company has been approved to spend X amount of dollars, and there's so much time to finish it, and you have one attempt to get it right. So it's not like you get to go back and say, oh, we screwed up, let's start this over again. At Riot, due to the success of the game, we had the full support to get it right. Since we started, we've started over 3 times. And we feel now like we've gotten it right, and I'm going to talk about that today. we certainly didn't get it right the first time. We were formed in 2011. Riot didn't know what to do with mobile. So we were tasked as a team, a small team, to figure out what mobile means to Riot Games and deliver it. We wanted to deliver it on both iOS and Android, so we had, kind of like Noah's Ark, we had 2 iOS, 2 Android, except we only had 1 back-end developer. We had some other team members, like a product owner, some QA, and some designers, and we set out to try to build what we thought mobile was for Riot. It turned out to be a bit of a kitchen sink app. We had all kinds of features. These are just some of them. We had LOL News, which was news about the game. We had Twitter, which displayed tweets from specific curated accounts and allowed you to interact with those. We had Reddit. We had Tumblr to display fan art. We had champion information. And we also had chat. So if you're familiar with the game, the way the game used to work is that the only time you could really talk to your friends in the game is if you were sitting in front of your computer. This is making an assumption that you may not know the true identity of the people that are your friends in the game, because the friends have a special name called a summoner name. And there are a lot of players that don't know the true identities of their friends. And so in order to play with your friends, you had to be sitting in front of your computer with League of Legends game up, trying to coordinate games to play. So we thought, let's try and extend that so that we can allow friends to play with one another without actually physically being in front of the computer. As I said, we had 2 different tracks, iOS and Android. And both of us set out separately. Even though we were on the same team, we were kind of like 2 separate teams. And I was on the iOS team. Both of us built MVC-ish type apps. Everybody, is there anybody that does not know what MVC is? It's okay if you don't. I'm assuming that we do. Okay, way in the back. MVC is a very common architecture that I'm sure we all follow or have followed on how to build your apps. And it separates your app into 3 pieces. Views, which are like this, controllers, and models. Models are classes that model some real-world concept. And I'm not going to go into much more detail than that, but I think everybody is probably generally familiar with this. This architecture was first introduced in the 70s as part of the Smalltalk language, which I actually was fortunate enough to learn object-oriented programming with. And it's been around forever, and millions of years in terms of programming years. And it is the way you're supposed to build front-end apps. What we would do in the app is we would reach out when the app launched and hit some services on the back end, get back JSON or XML, parse those into instances of model classes, and cache them up in memory. All over the place. We had lots of them. So just using the chat feature as an example, we would go out and log into chat, request our roster, which is all your buddies, get back all the buddies. Some of the players we have a max of 300 buddies on your list. So you might get 300 of those, all in memory. There's a lot of data that we keep with each buddy. And then all the other stuff that comes in, which I'll explain in a little bit. All that was hoisted up into memory and stayed there throughout the lifetime of the app. So you don't have to be embarrassed, because I'm admitting we built our app like this. Does anybody else, have they built mobile apps this way? Okay, good. I'm not alone. So we did this because at that time, 2011, Everybody on the team came from either a web or a desktop background, and that's how you do it. In fact, Riot is currently building a new desktop client, and this is the way they're building it. All the data comes in, it's being instantiated into models, and it's stored in memory. There's no local persistence. So every time you relaunch the app, we would go through that process. Hit the endpoints, get data back, rebuild everything in memory. This is an example of one of our abstractions. This is the donut, which was the way to diagram objects that I first learned when I read Designing Object-Oriented Software, which is a book by a lady named Rebecca Wirtz-Brock. And this is how she taught to visualize what an object looks like. The inside is private. The outside is what that object exposes to the world. The only way that you can communicate with that object is through the outside. So I chose to use this as a mechanism to show one of our abstractions, which was a buddy. And here are some of the properties. JID stands for Jabber ID. Jabber is a chat server, and that's the one we use at Riot. And it is a unique identification of a chat user. So we had things like JID, summoner name. We could add a note about a buddy because we may not know who they are, or whatever. We have group, so you can group your buddies, like these are the buddies I play with on Monday night, these are the buddies I play ranked with, these are the buddies that I work with, etc. And then we have a collection of presences. And I'll explain that in a second. The outside is the functions or the behavior that that buddy exposes. So I'm not going to go into detail there. Another one we had was presence. Presence, when you log into a chat system, you broadcast to the chat server, hey, I'm here. And the chat server then sends that presence to everybody that's on your buddy list so that they know you're now there. So when you're logged into multiple places, like a desktop client and mobile apps, you broadcast multiple presences, so you have multiple presences. And we wanted to prioritize all of your presences so that we displayed you in a preferred way. For example, if you were logged into the desktop client and mobile, the desktop client is deemed more important, so that's the one we prioritize. The point being, we get multiple presences. And if a buddy list is 300 long, and there's multiple presences for each, they all come in asynchronously. Like the chat server starts throwing them at us. And we had to handle all those, look them up in memory. Oh, this is a presence for Melissa. She's online. Go find it in memory, add it, causes these events to occur, the view updates. So here's the example I was just explaining. So we have, here's my buddy list. I have a bunch of them in memory. I have a bunch of presences for each person. Every time one comes in, I have to call add presence. We had event dispatching mechanisms so that the model dispatches a change event when it changes, so that anybody observing, like the view controller, can say, oh, my roster changed, and then can notify the view to repaint itself. So that's kind of key in the whole MVC architecture. We had a big problem though. We found ourselves as a team spending all of our time dealing with this. Like, we had all these model classes. This is just a very small subset of the chat feature. Remember I mentioned we had several other features, and that was just some of them. We had all kinds of models. Consequently, we had all kinds of data. We had all kinds of events flying around constantly because things are changing all the time. We have new news coming in. We have presences changing. We have buddy invites coming in. The other thing is, when a player goes into a game, they send a new presence that says, hey, I'm going into a game. When they come out of a game, we get another present. So when you have 300 people, it's pretty much, especially in prime time like in the evening, you're getting lots of changes all the time. And we were getting this proliferation of events throughout our app which was causing performance problems. Lots of things were occurring on the main thread. We just had all kinds of issues. We were finding we were spending all kinds of time, like, how do we solve this? And so we were also finding, for example, sometimes we would have 15 repaints on the roster. Like what? And trying to throttle those. It was just, all of our time was spent on this instead of making the app look cool. In the meantime, we had the Android team trying to do the same thing in their own way. Two completely separate code bases, and there was lots of bickering. Like, one of the Android guys, in fact, told us, oh, the iOS app is so bad, I just uninstalled it. We're like, why would you say that? You're on our team. Don't act like that. But that's how we behaved as a team. Even though we were a team, we were very adversarial. Lots of bickering. Oh, this way is best. No, this way is best. And we were truly two separate teams. We would have people come stop by our area and say, hey, when is the mobile app shipping? Well, we couldn't answer. We were spending all our time trying to fix and figure out what's wrong with it. And then we would have new features that were requested that we would have to implement in both. And we were just, we could not answer when we were delivering. It kept slipping. We kept feeling more and more pressure. And then one day, some of our managers showed up in our area and they said, you need to come into a room. They ushered us into a room and closed the door and they said, we're reorganizing this team. You guys have been at this for over a year and you can't tell us when you're delivering. You're showing us the app, but there's all kinds of problems. We're going to take the leadership of this team and reassign it. One of the advantages of being an engineer, I guess. Those people got moved to other teams. They assigned a new set of leaders to our team to help us figure out how to fix this. They also said, you as a team need to choose if you're going to move forward with this or you're going to scrap it and start over. Also, we're going to require that you all work on the same team. So there's not two teams anymore. We're getting rid of iOS, which freaked us out, the iOS guys, and we had to learn to do Android. And so we kind of took that as a warning, like we better figure this out. And so for the next 2 weeks, we met and tried to figure out what we wanted to do. We knew starting over was an option. We also knew that using the existing code base was an option, which was all MVC-ish. We both suffered from the same general problem, though. All these objects in memory all the time. Classic MVC. So, we, at Riot they call it siloing, when engineers are dedicated to one thing and they don't want to like lift their head and learn other things, and they also said no more siloing. So we truly became one team. All four of us working together to solve the same problem. After 2 weeks, the lead Android guy decided this was not going to work for him. There was still too much bickering. He was tied to his original implementation. He felt good about it. We didn't. He asked to be removed, and he was. He moved to another team. In his place, we brought in another guy who was not a mobile developer, but was highly interested in developing mobile apps. And the only thing he could say was, I went to a Google I/O and I watched a presentation that tells us how to build mobile apps. And I went home after that and I built an app in the style that I was taught, and it's amazing. So we watched this, and I encourage you to do so. I have a link at this at the end of the presentation. Although it's about Android, it changed everything. And this is kind of the root of this talk. It changes what the architecture is for mobile apps. It's an hour long, and yes, it's from 2010, which seems like it might not be relevant anymore. The other thing that I did when we watched this I have a lot of friends that do Android, and I asked them about this. Do you build apps this way? Nobody. I have no idea why, but I'm going to hopefully enlighten you on the way Google suggests that you build mobile apps. We adopted this way, even for iOS. So let's jump in. The key concepts here, we still have a semblance of the MVC architecture, but we have a view over here that makes a request of something called the ContentResolver. And the request is made in the form of a URI. So we have the URI chat roster. So that view controller really is making a request through its data source for a specific collection of data identified by a URI. The ContentResolver doesn't really do anything itself. Instead, delegates to one of the registered content providers that has notified at launch the ContentResolver which URIs it can handle. So if the ContentResolver can't find a provider, then it just says, I don't know how to handle this. But if it finds one, then it hands that request off to a content provider that is responsible for fulfilling that request. Here, as an example, I have 3 content providers that are registered with the Resolver. One called Data Dragon, and that's a concept in League of Legends where lots of the images in the game are stored, like champions, spells, items, etc. Profile icons, and we need all that in the app, as you can see here. And those are resolved from Data Dragon. So any Data Dragon request would be handled by this content provider. Chat here and Summoner here. Those are, I won't go into detail about what all these do. But each content provider can then choose what they want to do. Here, the typical way is that the content provider has a local SQLite data store. How many of you know SQL? Okay. One of the key takeaways from this session is that as a developer, I strongly encourage you to become a SQL expert. I learned it decades ago, and it is powerful. It is the second most powerful language that you will learn, in my opinion, aside from the programming languages that you use on a daily basis. The things that you can do with it compared to the code you have to write to do the same thing is amazing. The content provider also may choose to invoke remote services and store that data in the local data store. Anytime that's done, that content provider will dispatch through this thing called a content observer, hey, my data at this URI has changed, and the view controller in its view did appear will, through the ContentResolver, say, add me as a content observer for these URIs. Anytime anything changes, I want to know. So you can kind of see how this architecture folds in some of the key concepts from MVC, change events and models, observing those changes, etc., and still having the different layers. But these things are completely decoupled. This doesn't know about this or this, and so you still have the nice clean separation. So what happens is when the chat roster is requested, it goes through the ContentResolver, which delegates to a provider, which may go out, execute a remote service, store it in the database, then through the resolver say, hey, my data's changed. This thing looks up to see if there's any observers that are interested in changes for specific URIs and notifies them. And when the notification occurs, that may cause the view controller to go make another request to get the refreshed data. So there's a couple of key things I want to deep dive on here. URIs. Everything is identified. Every bit of content in your application is identified by a URI. Everything. So models represent data in your application, and replacing that traditional model with this allows you to consistently represent the data in your application using these URIs. And URIs are a very well-known concept for engineers. So here we have a URI called chat roster, which you would expect identifies a list of buddies. I can also have groups in my roster. So this you would expect would identify a list of roster groups that I've identified. Here is a specific group. This is a specific list of buddies in that group. This is the Monday group that I play with on Monday nights. And this is a specific player in the Monday group in my roster. And just here's a completely separate, using a configuration URI for North America. We have a chat server. So just an example of a completely different, out of context URI. The key point here, all data is identified uniquely by a URI. The second thing, which I showed you on that diagram, is the ContentResolver. It has a very simple API. I've expressed it here as a protocol. So it has 4 data-related functions that roughly equate to CRUD and or some common HTTP verbs. Insert being equivalent to create on CRUD, and post on an HTTP request. Update equivalent to put for HTTP, and the U in CRUD for update. Delete, the same for both. And query, the equivalent of read or get. So we also have 2 event-related functions down here. You'll notice that the data-related functions, actually all of them, take as their first argument a URI. And this allows the ContentResolver to delegate to one of the content providers. Now, the insert takes a dictionary of values that are being inserted, and that would be, the key would be the name of the property or the name of the value, and the value would be the actual value itself. Same thing for update, except we have this thing called a selection, which I'll dive into here in a second. Delete, a URI with an optional selection. And then query, we have quite a few things here that we can optionally pass. Starting with the URI, we have a projection, selection, grouping, and sorting. And the thing I want to point out is that we get back a result set. So, what that means is that every single view controller interacts with the model layer the same way. Every single one. We don't have 50 model classes. We don't have parsing to get these models instantiated. We don't have all these properties we have to declare, and I realize with things like core data and Realm, there's probably tools to do all that, but you don't have any of that with this architecture. Your dependencies, instead of being on model classes, is on primitive data types, typically. That being strings, numbers, Booleans, and dates and times. When we first started this, I was very skeptical, because it felt like, oh, we're going back to the 90s again. Because this was kind of a 90s thing, like doing the like things like Power Builder, if any of you ever did things like that. It felt very 90s. But we've been doing this for a long time now, about 2 years, 3 years. And it's amazing how you just clear your mind of all the models and you don't have to even deal with any of that. Everything is this and a result set. So I want to deep dive into some of the concepts on that last slide. Projection. One of the weaknesses of MVC is that you get all this data back and you have to keep it somewhere. And when you have it in memory, you instantiate a model object and you populate every one of its properties because you don't know where you're going to use it. So this is a subset really of what our buddy looks like. It really has maybe like 40 or 50 different properties. So you can imagine this thing going way out there. So for every one of those, we have a lot of data. And so the point being, I don't need all that data every time I use it. When I'm displaying the roster, I might only need a couple of pieces. So when I cut all of that off, that's a significant. Really? Okay, I better hurry. That's a significant savings. One of the things in that Google video is, as a mobile developer, this is becoming less and less true, I guess, over time, but your devices operate under limited constraints. There's lots of apps that you have to share resources with, memory, processing power, the radio when you go do network operations. So you need to be a good citizen of the platform. Don't take up gobs of memory if you don't need to. So this concept of projection is a huge savings in memory. On a particular view, I only can ask for exactly what I want. The next concept is the concept of selection. So projection allowed me to select which data elements I want. Selection allows me to select which rows I want. So in this case, I might only need the players in the work group, and I can further constrain that to be those that are online. And each view controller can ask for specifically what it wants. The last thing I want to talk about here is sorting. Typically when you have models in memory, you have to sort them with code. Using this mechanism, you can also sort. Here, I want to sort alphabetically by summoner name, and I can get my data back in the order that I want it, where I need it. The cool thing is that I can combine all these into one request. So I can apply projection, selection, and sorting, and hand that off to the back end of the front end, and this is what I get. Instead of this massive amount of data that I'm having to manage. So this is your new model, the result set. It's old school maybe. This goes back to a time when we would access databases directly. But the SQL, I can tell you, I know SQL the best on my team, and I've written some really nasty SQL statements, but the power that it provides to the front end is amazing. Like, what we can present just to the front end and not have to deal with it, the front end being the view controller and the view, the back end being this other stuff, which is still part of the app, it just simplifies everything. These concepts of projection, selection, sorting, also grouping, which I didn't go into. But this is the new model. So this is sort of the key point of this presentation. Instead of having all of these classes that you need to either generate or manually create with all these properties, you use something that equates to a SQL database. And it simplifies everything and gives you a huge amount of power in both memory, consistency. Like I said, every view controller has the same interface to the data, to the model layer. You get just the data you want, in the order you want, and by using this, it works perfectly as the data source for your UI table view or your collection view. So I was listening the other day to a presentation by Janie Clayton. Does everybody know who she is? And she made a statement about, as iOS developers, all we really do is get data and put it in a UI table view controller. And I thought, every one of our views in our app is a table view controller, and I guess she's pretty correct. So this fits perfectly into that. In fact, Android has a mechanism to bind the live result sets from queries directly into your view controller. So we don't quite have that. So to close the story out, where are we now? I said we rewrote the app 3 times. Our team got rebranded as the Always Available Friends team, which internally, I don't know if I should say this or not, internally we refer to ourselves as Always Available Friends with Benefits. So we own 4 products. We own the mobile iOS, mobile Android, the legacy client, which long ago when I first joined Riot, I wrote that, much of that. That's the client that if you play League of Legends, when you launch it, when you double click the icon and it comes up and you log in, that's the code I wrote. It was written in Adobe Air. And then the new client, which is in alpha, coming in beta hopefully by the end of the year. We own the social panel. We do the same thing across all of these. So after we spent about 6 months doing Android and figuring out how to build this the correct way, building it the way I just showed you, we were again given the opportunity, not the same sort of way, but we started over again a 3rd time because the problem we wanted to solve the 3rd time is we don't want to write 2 separate stacks. Now that's beyond the scope of this session, but I'm happy to talk to you about it if you're interested, about how we are able to write code once, and we share about 70 to 80% of the code between these two without using something like Xamarin. I'm happy to go into that if you're interested. But what we've done is we've standardized on our URI structure across these 3 products. This one is legacy and it's nasty and we're not touching it unless we have to. So we as a team, we now are much bigger. We're about 20 people and a lot of people working on that. We use the same URI structure here and here to identify data. And the next step for us as a team is to write a test harness that we can lay an HTTP server over the top of this and over the top of a framework that we've written that packages up all that content stuff and execute tests to make sure everything is working as we expect. So we're unable to share code here, unfortunately, for technical reasons. But here we have, by re-architecting a 3rd time and starting over, we're able to share a lot of code. We write it once and both benefit. We spend our time now on the UI, which is where we should. So we're also healed as a team. We don't bicker. If we bicker, it's healthy bickering because we were forced to work together on the same thing. So if, another key takeaway, for us, that worked fabulously. Like if you are bickering in your team, remove the barriers, make everybody work together. It had a magnificent impact on our team. Okay. I got a little ahead of myself. Okay, in summary, am I going to make it, John?
Yep.
Dump the traditional model layer. You don't need all those classes and all those properties and all those change events. Dump it. Favor result sets as your model layer. It's consistent. Every single view controller has the exact same model. It's a result set. and they acquire data the same way. They pass a URI. They can use projection, selection, grouping, and sorting. Learn SQL. If you don't know it, learn it. It's extremely powerful. Employ standard techniques, RESTful approaches, and usage of URIs. They're well understood in our industry. And profit. Have a great conference. Thank you.